So-called feature selection is an important part of building a classifier. The term feature is a synonym for attribute or property. An email message contains many features, such as the sender's email address, the message date and time, the IP address of the sender's email server, whether the email message contains attachments, the subject line text, the body text, etc. We need to determine which of these features help us predict whether a given message is spam. And the process of choosing them is known as feature selection. As another example, imagine your goal is to predict the cost of a house. Which features would be important for doing this? Likely the location, the number of bedrooms and bathrooms, the lot size, the construction material, and the age have a substantial effect on the price. The color of the house is probably less important than those, but more important than the species of grass in the lawn or the height of the mailbox. Some features can be discarded simply because they're redundant. For example, we may not need to store both the width and length of the lot because storing its area might suffice. Knowing which features really matter helps us build more accurate models and can also help improve performance since there are fewer attributes to store and consider. Now let's turn to talking about feature selection when our data is text, in this case, email messages. We can compile statistics on the words in the email messages. Thus, for example, we could see that 35 out of 40 messages that contain the word Rolex are spam, while 98 out of 215 messages that contain the word the are spam. Intuitively, the term Rolex is a better predictor of spam than the word the. Practically all English language emails will have the word the. We can't tell whether the word Rolex is a good predictor of spam with just the information presented. If our inbox contains 1 million messages and 400,000 messages are spam, then the presence of Rolex probably does not matter that much. So what we need to also know the number of messages that did not contain the term Rolex and the number of messages that were examined. So this contingency table has the information we need to characterize the predictive strength of Rolex. We need the number of messages that contain Rolex and are spam, the number of messages that contain Rolex and are not spam, the number of messages that do not contain Rolex and are spam, and finally the number of messages that do not contain Rolex and are not spam. We need contingency tables like this for each word in our emails. Given contingency tables for each word, we can compute a statistic called mutual information. We will use mutual information to help select relevant features. Mutual information values range between 0 and 1. Words with lower values are poor predictors, and words with values approaching 1 are good predictors. We can calculate mutual information for all words in the set of messages. But mutual information is not itself the classifier. It's a technique for determining which features should be used in a classifier. We'll pick the ones with high values. So, for example, Rolex will have a high mutual information value, while the will have a low value. We'd run the risk of overfitting if we included words that seldom occur or do not provide a strong signal that a message is or is not spam, since such words would effectively be noise in our dataset. By the way, you'll do something similar in the hands-on exercises. You'll use R to calculate mutual information for all words in users' bleats. Then you will select the words with high values, that is, the ones that are the best predictors of high play counts. Those words will be features in our classification model, and then we'll illustrate how to calculate this probability using Bayes' rule.